Hello, my fellow chemists. In this video, we're going to take a look at the difference between ionic bonds and covalent bonds. This is listed as an intermediate level video because it assumes you have a basic understanding of bond energy and atomic energy. If you need a review of those topics, I'll put a link in the upper right-hand corner. So, ionic bonds and covalent bonds. The basic definition is an ionic bond occurs when you have an atom that loses one or more electrons and then another atom gains one or more electrons. And in a covalent bond, that occurs when you have atoms that are sharing electrons between each other. So let's first take a look at an example of an ionic bond. So the atoms that I chose for this is a sodium atom and a fluorine atom. You can see that fluorine is in the upper right-hand corner of the periodic table, so it has a very high electronegativity, ability to try to pull electrons towards itself. And sodium is over on the left-hand side of the periodic table, so it has a relatively low electronegativity. It doesn't have much desire to pull electrons towards itself. Let's take a look at the model of the atoms to see if we can explain why. If we look at sodium, sodium has 11 protons, and it's neutral sodium. It's also then going to have 11 electrons. 2 in the first energy level, 8 in the second energy level, and then its last electron is in the third energy level. This is its valence shell. Remember, atoms want to fill their valence shell. They want to get an octet. In order for sodium to get an octet, it's going to have to pull 8 more electrons in. It's not going to want to do that. It's going to want to rather just give this electron away, because if it loses that electron, then its next highest energy level will be filled. That's why sodium has a very low electronegativity. But now if we take a look at fluorine, fluorine has 9 protons, so if it's a neutral fluorine, it's also going to have 9 electrons. 2 of them are in the first energy level, and then the second energy level for fluorine is its valence shell, and it's going to have 7 electrons. Well, fluorine only needs to gain 1 more electron to fill its octet, so it's going to have a very strong electronegativity or a very strong pull of electrons towards its highest energy level. So fluorine is going to have a very strong electromagnetic pull of sodium's valence electron. And what will happen is it will actually pull an electron away from sodium to fill its octet. And when this occurs, if we take a look, the whole third energy level of sodium disappears. And sodium now has a new valence shell. And that valence shell is filled with 8 electrons. And the electron then moves over into fluorine. And I'll draw that one in red. Sodium still has 11 protons, but now it only has 10 electrons. 2, 4, 6, 8, 10. Which means it has 1 more proton than electron, so sodium is now going to have a +1 charge. And fluorine still has 9 protons, but now it's going to have 11 electrons. 2, 4, 6, 8, 10, or 10 electrons, sorry. So it's going to have a -1 charge. Whenever atoms gain a charge by gaining or losing an electron, they are now called ions. So now this is a sodium ion, and this is a fluorine ion. Again, ions just have different numbers of protons and electrons. This is a sodium ion with a plus charge. This is a fluorine ion with a negative charge. Now that these atoms or ions have opposite charges, they are actually attracted to each other because of the opposite charges. And what will happen is these ions will get close to each other, and you will write them out just as NaF, and they are then called a molecule. And a molecule is when you have 2 or more atoms that are bonded together. So once the sodium and the fluorine become ions, their opposite charges will attract them to each other. They will then form a sodium fluoride molecule. So let's now take a look at an example of how a covalent bond will form. And the example that I'm going to use for a covalent bond is just 2 hydrogen atoms interacting with each other. So if we have 2 hydrogen atoms, they only have 1 energy level, and hydrogens each only have 1 proton and 1 electron. So we have 2 separate hydrogens. They each have a positive 1 charge for their nucleus, and they each have 1 electron. Sodiums, on the periodic table, they're the first element. They're obviously going to have the exact same electronegativity because they're the same atom. And what that means is this one this one hydrogen over here is going to pull the electron over to it at the same force as this hydrogen pulling its electron over here. So this is going to be the same electromagnetic force pulling electrons towards each other. So you can think of these two little hydrogens as having a tug of war for their electrons, because each one wants to get 2 electrons in its outermost shell, because the first energy shell can only hold 2 electrons. But neither one is strong enough to pull the electron away from the other one, because they have the same electronegativity. So what they're going to decide to do is share electrons. And when they share electrons, it counts as the electron belonging to each atom. So if I kind of draw these atoms where their electron clouds are overlapping. So they're getting close to each other, but not so close that the nuclei really repel each other. So the nuclei are still kind of far apart, but the electrons are now able to overlap with each other. And when this occurs, these electrons count for both atoms. Now that means that this hydrogen on the right-hand side is counted as having 2 electrons. And this hydrogen on the left-hand side is also counted as having 2 electrons. So they've filled their octet, or in this case, they filled their duet, their outermost valence shell, with 2 electrons. Now, this would be drawn out as a hydrogen and then a line and another hydrogen. They would also be considered a molecule because they are bonded or attached to each other. But this line represents 2 electrons that are being shared. You don't draw that line in there for ionic bonds, only for covalent bonds. So that's an example of a covalent bond. The last example I want to take a look at is a specific type of covalent bond, and it's going to be called a polar covalent bond. And a polar covalent bond forms when you have 2 atoms that have pretty similar electronegativities, but they're not exactly the same. So one atom's not strong enough to pull electrons away from the other atom, but the electrons are not going to be shared evenly either. So for the example for our polar covalent bond, we're going to take a look at fluorine and hydrogen. Now, fluorine is going to have a higher electronegativity than hydrogen, but it's not going to be high enough to just pull hydrogen's electron completely away from it. So they're still going to have their orbitals overlap and they're going to share electrons. So again, fluorine has 2 energy levels, whereas hydrogen only has 1. And fluorine has 9 protons and electrons, and hydrogen only has 1. So here's our hydrogen, and here's our fluorine. Fluorine again has 2 electrons in its first energy level, and it has 7 electrons in its second energy level, and its second energy level is its valence shell, its outermost shell. So now this fluorine is going to try to pull this electron over so that it can fill its octet and have 8 electrons. So this is a pretty strong pull. And the hydrogen wants to get 1 more electron to fill its highest energy level, so it's going to have a fairly strong pull over here as well. But it's not quite as strong as fluorine. So these 2 atoms are having a tug of war, trying to fight over these 2 electrons, and eventually they're going to decide neither one of us is strong enough to pull an electron away from the other one, so let's share electrons, just like we saw in that example with the 2 hydrogens. And again, what will happen when they share electrons is you will have their outermost energy levels will overlap. And again, they don't get so close that the nuclei start to really repel each other. So again, we have our +1 here and our +9 for the fluorine. The fluorine has its 2 electrons in here still. But now I'll draw hydrogen's electron in red. And what you can see is hydrogen is counted as having 2 valence electrons, and fluorine is counted as having 8 valence electrons. So if we were to draw this out, it would be H with a line F, and this would be now another molecule because it's 2 or more atoms that are sharing electrons. But the electrons are not going to be shared evenly. If I were to show you where the electrons spent most of their time, and I were to do that with, say, this blue highlighter here, the electrons are going to spend most of their time around the fluorine and much less of their time around the hydrogen. Because the fluorine does have a higher electronegativity than the hydrogen, even though it wasn't high enough to pull the electrons completely away from the hydrogen. So we would say that the part of the molecule where the fluorine is partially negative, and the part of the molecule where the hydrogen is, we would say that that is partially positive. So when you have a polar covalent bond, you're still forming a molecule, you're still forming a covalent bond, but the electrons are not shared evenly. They spend more of their time near the more electronegative atom. So they spend more time near the fluorine, so that's partially negative, and less time around the hydrogen, so that is partially positive. Now, the last thing that we want to talk about in this video is the relative strengths of these bonds. So if we were to put a little diagram up here for bond strength, and then list these 3 types of bonds on it. So over here we'll have strong bond, and then relatively over here we'll have weak bond. Now the strongest of these 3 bonds is the covalent bond. Then the intermediate strength one would be the polar covalent bond. And then the weakest one would be the ionic bond. Now, how much stronger or how much weaker, it's really hard to say because different covalent bonds are different strengths with each other, and different ionic bonds are different strengths with each other. But in general, a covalent bond is stronger than a polar covalent bond, and a polar covalent bond is stronger than an ionic bond. All right, that's it for this video. I hope you learned something. If you did, make sure to subscribe and like, and I'll see you for the next lesson.